Hi, in this video we are going to talk about queue in Java. Before we discuss queue, let's do a quick recap of queue data structure. Queue data structure works like a normal queue, like a doctor's queue or a queue for tickets, where the person who comes first goes out first. Same thing if we need to implement in programming, if we have a collection of items and we want to have the collection in such a way that the item that came first has to leave first and the item that came latest leaves latest. If we want to implement such a structure, we need a queue. In Java, queue is an interface. It's not a class like other languages like C++. Queue is an interface that says that if you are a class and if you implement queue interface, you need to implement these operations. And queue interface is implemented mainly by these two classes. One is linked list and one is ArrayDQ. We also call it ArrayDeq. So linked list class is a doubly linked list implementation and ArrayDeq is an array implementation of queue. Queue interface inherits from collection interface. Collection interface in collections framework is the root of all the main collections and it has basic functionalities for knowing the size, adding item, and queue interface, since it inherits from collection, it also has all those methods. And classes which implement queue interface should have all the methods which are present in collection and all the methods which are present in queue. Let us now take a look at first program that uses queue interface. So in this program, we have created a queue using an object of ArrayDQ. Please note that if you replace this line with this line, your program will work exactly the same way. That's the advantage of having interfaces. Since you have queue as an interface, whatever classes implement the queue, you can just change the right hand side and rest of the code is going to be same because you are using queue functionalities, right? And you have a reference of queue type. So this way your queue can be changed also. If you pass a reference of queue type to a function and if you decide to later change the implementation, you can do that as well because it's just an interface which is implemented by multiple classes. And if you want to change the implementation, you can just change this line to linked list and your rest of the code remains same. Now, which one should be preferred? Should we use ArrayDQ or should we use linked list to implement the queue data structure? See, ArrayDQ is an array implementation and linked list is a linked list implementation. So they have both their advantages and disadvantages, but in general, ArrayDQ is preferred. Reasons are, since it is an array, it's going to be cache friendly and it's going to be faster. Please note that time complexities for adding items and removing items are big O of 1 in both linked list and ArrayDQ. But the difference is, in linked list, it's worst case big O of 1. It's never going to take more than constant time. But in ArrayDQ, it's amortized big O of 1. So what do we mean by amortized? Amortized means if you're doing n operations, then if you take the average of those n operations, it will come out to be constant. But if you have a particular operation which causes resizing of the array internally, then that particular operation can take linear time as well, big O of n time as well. So in general, array implementation is better, but if you are very particular about individual operations, you don't want any operation to be slow, like some real-time environment, then you might want to prefer linked list because linked list guarantees the worst case and ArrayDQ has amortized constant time. Okay, so this is implementation of queue using two classes. I have implemented using ArrayDQ. Offer function adds an item to the end of queue. So when you have a queue of items, a queue of people, right? You have a person who is at the front of queue and you have a person who is at the end of the queue, right? This is a person who is at the end of the queue, right? We call it rear in data structures. And in Java terminology, we call it last and we call it first, right? So when you add an item using offer function, the item is added at the last. And soon we'll talk about removing an item in the next coding example. When you remove an item, the person is removed from the first, right? That's how queues work. The person who came first has to be removed first, right? That person should be served first. And when you are adding an item, when a new person comes into the queue, that person is added at the end last of the queue. So in this example code, we are adding 10, then we are adding 20, then we are adding 30. then we are trying to get the size of Q. So size function is a collection interface function. It's there in all the collections that come through the collection hierarchy, right? So what are we going to get? We are going to get the size as 3. IsEmpty function is also part of the collection interface. So if you call IsEmpty, you are going to get false as a result, because this queue is not empty. It has 3 items. Now if you print the queue, you will get the items of queue 10, 20, 30. Let us now take a look at this another coding implementation. Here we have a queue, then we are again adding items 10, 20, 30. So this is how our queue is. This is first and this is last. Now let's see the peek function in Java. The peek function gives you the next item which is going to be removed, which is first item of the queue. It does not remove the item though. So it just tells you the first item of the queue. And first item here is 10. So it's going to give you 10. Now this peek function returns null if your queue is empty. If queue is empty, then it's going to return null. Poll function, it removes the first item and returns the removed item. So peek function did not remove 10, it simply returned 10. But poll function removed 10 and returned 10. So we also get 10 here. So now after you have called the poll function, your queue has 20, 30 only. Now if you call peek function, you are going to get the first item of the queue, which is 20. So next output is 20. So we have talked about these functions: offer to add an item, peek to know the first item, and poll to remove an item. And when you add an item, it is added at the last. When you remove an item using poll, it is removed from the first. Let us now talk about more functions in queue interface. We have already talked about these 3 functions. Peek function is to know the first item or get the first item. Offer function is to add an item at the end of queue or last of queue. Poll function is to remove the front item. These 3 functions have their counterparts as well. These 3 functions do not throw an exception. For example, if queue is empty and if you call peek, it's going to return null. If you have a capacity bounded queue where the capacity is bounded, and if you are adding the items beyond the capacity, then this offer function is going to return false. It has return type as boolean. If it can successfully add, it returns true. If the capacity bounded queue is there, then it returns false. Generally, the queues that we create are not capacity bounded queues, right? Those are different queues that are capacity bounded, and we use that return value in those cases when you have capacity bounded queues. Poll function, if you call poll function on an empty queue, it's going to return null. So peek has counterpart element. If you are going to call element function on an empty queue, then it's going to throw an exception. Otherwise, it works same as peek, right? Add function, again, it works as offer in general, but if you have a capacity bounded queue and if you are trying to add an item beyond the bounded capacity, then it's going to throw an exception. Remove function, if everything is fine, then it's same as poll function. The difference is poll is going to return null if the queue is empty. If queue is empty, then remove is going to throw an exception. Let us now talk about time complexities of these operations. All these operations have big O of 1 time complexity. Whether you implement queue using linked list class or you implement using ArrayDQ class. Linked list class is simply a doubly linked list where you have references to head and first and last. And when you have references to first and last, you can easily add and remove items at both the ends. So using linked list, queue can be implemented with big O of 1 time complexity. Now talking about ArrayDQ, ArrayDQ is a DQ implementation using dynamic sized arrays. And one possible implementation of ArrayDQ is circular array. And with circular array, you can do all these operations in big O of 1 time. According to Java documentation, ArrayDQ has time complexity as big O of 1, which is amortized big O of 1 for all the 4 operations: inserting at the first, deleting from the first, inserting at the end, deleting from the end, which is pretty much possible with a circular array implementation. But please note that we don't need all 4 operations in queue. What operations we need, we are going to add at the last, right, and remove from the first. So we need 2 operations out of these 4. And all these operations are big O of 1. Whether you use linked list, it's in linked list, it's worst case big O of 1. In ArrayDQ, it's amortized big O of 1. Before we end this video, let's quickly talk about applications of queue. So queue is an interface and implemented by these two classes in Java, and it has many applications. Wherever you have a single resource which is to be consumed by multiple people. For example, a web server or a server where multiple requests are coming, and you want to assign these requests or respond to these requests according to their incoming order. So what you do is you enqueue these requests, right? There are many queues in our operating system. When we study operating system, we study first come first serve scheduling, FCFS scheduling, right? Which is implemented using queue. The mail services in our system, mail queue utility, it is a queue which has a queue of emails. So queue is always useful when you have a single resource like a doctor and multiple patients who want to attend the doctor, and all these patients, if you want to be fair, you want them to be assigned in first come first serve basis, then you create a queue, right? Similarly, there are many queues for different resources in our operating system, in fact in our networks. So when you have router where multiple packets are coming and you want to deliver these packets in the same order, you put these packets in a queue. So whenever you need a queue, whenever you need a buffer, you use queue. So talking about the buffer, when you have a slow device and a fast device, there also you use a queue. For example, our keyboard and processor. Processor is really fast device and keyboard is really slow. And if while we are typing, the keyboard processes the characters slowly and processor can quickly process them. So what you do is, to synchronize the speed, you create a queue. So you create a queue of the items typed by the keyboard. Whenever processor gets time, it quickly gets all those items and processes them. So when you have a single resource shared by multiple people, or when you have a slow device and a fast device and you want to synchronize them, you use a buffer. Buffer is nothing but a queue.